Yangshan Quarry is generally presented as the remains of an exceptionally ambitious but ultimately unsuccessful Ming dynasty project. According to the familiar account, the Yongle Emperor ordered 3 enormous pieces of limestone to be cut for a commemorative stele at the tomb of his father. These stones were shaped as a base, an upright tablet, and a crown, but were abandoned after the builders discovered they were just too heavy to transport. The dimensions commonly assigned to these 3 masses are extraordinary. Nanjing's official local history office describes the alleged base as being approximately 17 meters high, 29.5 meters wide, 12 meters thick, and weighing more than 16,000 tons. The proposed stele body is estimated at nearly 9,000 tons, while the supposed crown exceeds 6,000 tons. Together, these 3 pieces would have made up a monument totally unlike anything known to have been transported or erected in Ming China or anywhere else in the world, ever. The conventional explanation seems straightforward only when each part is considered on its own. But once you start combining the parts, it becomes less an explanation and more a collection of contradictions. Why would experienced imperial quarrymen isolate stones whose approximate weight could have been estimated long before the work reached such an advanced stage? And where is the infrastructure that would have been required to lower, load, transport, turn, raise and support even the smallest of the 3 masses? Where are the graded roads, foundations, hauling installations, staging areas, and traces of a receiving project that would be proportionate to such a massive undertaking? Ming builders could certainly move very heavy stones, but the documented examples show both the limits of that capability and the logistical preparation it required. For instance, the famous large stone carving transported to the Forbidden City weighed more than 300 tons and was hauled over a specially prepared winter route using a wooden sledge and water-lubricated ice. It was an impressive engineering achievement, but the largest Yangshan mass is conventionally calculated at more than 50 times that weight. Where, moreover, is the administrative shadow of the Yangshan project? A civilization capable of organizing such a monument would have needed labor drafts, provisions, tools, roads, supervisors, accounts, disciplinary procedures, medical support, and communications between the quarry and the imperial court. Yet, the principal contemporary account is not a technical or administrative record. It's actually a short literary description of an official excursion. In the year 1405, the court scholar Hu Guang wrote that the emperor had ordered stone cut at Yangshan for a monument at Xiaoling. Hu described one exceptional stone, gave its dimensions, and recorded several hundred temporary huts, wells, a stone pool, a deep pit being filled with excavated material, and the sounds of workers moving stone. He did not describe 3 designed components, a complete monument, a transport route, or a method of erection. Looking upward, he and his companions saw a giant stone rising like a city wall and remarked that heaven seemed to have produced it in anticipation of the emperor's purpose. That text establishes a Ming episode at Yangshan. It does not establish the Ming creation of everything now visible there. In fact, it implies that the great megalith described pre-existed the effort. Then there is the problem of the missing inscription. It has been suggested that Yangshan was created to be left in place as monuments to the emperor's greatness or a political statement. But a Chinese stele is not simply a large upright stone. Its cultural function is epigraphic. Steles preserve decrees, commemorations, religious texts, names, accomplishments, boundaries, histories, and exemplary calligraphy. Museum collections preserve Chinese steles whose identities and purposes are inseparable from the texts carved upon them. At Yangshan, however, there is no imperial dedication, no title panel, no preliminary ruling of an inscription field, no engraved name, no fragment of commemorative language, and no visible effort to turn the alleged steely body into a textual monument. There is no inscription on the great external faces. There is no writing inside the cut spaces. There is no explanatory text on the accessible surfaces that might have transformed the abandoned quarry into a deliberate memorial. An unfinished quarry, blank, need not yet have been inscribed. The silence becomes more significant, however, when the quarry itself is said to have served as a political statement. What statement could it make without identifying its ruler, its subject, its purpose, or even its intended form? A mute mass hidden in a quarry cannot perform the normal communicative work of an imperial stele. The stones also possess positive features that the usual explanation does not satisfactorily address. They contain large projections or knobs, deep recesses, undercut spaces, piers, shelves, platforms, and forms that resemble benches or tables. Some may be quarrying remnants or temporary supports. Yet simply naming them supports does not explain their complete distribution, their proportions, their accessibility, or why certain spaces appear more elaborate than the minimum requirements of stone extraction would seem to demand. What if the contradictions arise because the site has been placed in the wrong category? What if Yangshan is not an unfinished monument at all? To approach the site differently, it is necessary to begin far from Yangshan, with a problem faced by every complex society before the development of mature writing. Human spoken language is vastly older than civilization, agriculture, or monumental architecture. Pre-literate people were not proverbal, nor were their languages necessarily rudimentary. Oral cultures can possess elaborate grammars, extensive vocabularies, specialized ecological knowledge, and sophisticated narrative traditions. The bottleneck was not an inability to speak or think. It was an inability to preserve large bodies of precise, revisable information outside living human memory. A story can carry lore, identity, cosmology, and moral instruction across generations. A song can preserve a journey or a genealogy. Ritual can stabilize sequences of action. Apprenticeship can transmit bodily skill. But how does an oral society preserve a complicated technical system when its correct performance depends on measurements, proportions, causal sequences, conditional operations, and knowledge distributed among many specialists? How does it ensure that a support is removed only after another operation has been completed? How does it preserve the correct placement of a handling projection, the angle of a working surface, the sequence of an undercut, or the relationship between a block's thickness and the spacing of its support points? How does it teach a procedure that may take years to complete and may not be repeated within the working lifetime of every participant? The usual answer is apprenticeship. A novice works beside an expert, learns through observation and correction, and eventually becomes capable of reproducing the process. Archaeologists increasingly study prehistoric craft traditions in precisely these terms, not simply as collections of tools, but as communities of practice in which bodily knowledge, social identity, and technical competence were transmitted together. Apprenticeship, nevertheless, has weaknesses. Specialists die, communities disperse, population losses sever lineages of instruction, oral descriptions drift. Techniques become ritualized without remaining understood. A process divided among several classes of worker may survive only in fragments. Writing eventually provided a powerful answer to this problem, but writing did not appear fully formed. The earliest example of a complete written system that has been found was Sumerian cuneiform, dating to about 3300 BCE. In Mesopotamia, the pathway from physical counters to pictographic notation and then to script extended across millennia. Clay tokens were used from approximately the 8th millennium BCE to record quantities and categories of goods. Two-dimensional signs later replaced the three-dimensional counters, and only subsequently did writing become capable of systematically representing names, sounds, and open-ended speech. China preserves evidence of a similarly long prehistory of sign use. Incised signs from 7th millennium BCE Jiahu have been interpreted not as a completed writing system, but as ritual symbols belonging to a long developmental trajectory that eventually led toward writing. Between spoken instruction and mature writing, therefore, lay a vast field of possible information technologies, ritual sequences, mnemonic objects, standardized tools, tokens, images, marked bones, carved landscapes, canonical measurements, and permanent architectural forms. What if Yangshan belongs within that field? How would a pre-literate society achieve the task of organizing itself to better propagate knowledge? This is where the Yangshan Capstone Hypothesis begins. Monumental building serves a centralizing purpose. The process would not have begun with a sudden decision to excavate the largest possible forms from a mountain. It would have developed through experience. Smaller communal projects would have come first. Clearing, gathering places, shaping stones, building shelters, managing water, marking seasonal routes, constructing ritual spaces, or erecting modest monuments. Each undertaking would have produced an immediate result, but it would also have revealed something more consequential. Working together made the community more capable of working together again. A project involving several families or neighboring groups would require people to coordinate tasks beyond the ordinary scale of household life. Some would obtain stone or timber. Others would manufacture tools, prepare food, transport water, tend injuries, supervise children, or maintain the work site. Decisions would have to be made about sequence, responsibility, distribution, and authority. Even a relatively small construction would begin converting informal cooperation into repeatable organization. Success would demonstrate that the true product of collective building was not only the thing constructed, it was the social capacity created during construction. A finished platform, enclosure, or standing stone might serve a practical or ceremonial purpose, but the process of making it would leave the community with trained workers, improved tools, shared measurements, tested supply arrangements, and stronger relationships among groups that had previously operated more independently. People would return home carrying new techniques and new terms. The next project could begin from a higher level of competence than the last. Repeated construction would gradually reveal the value of continuity. A community that dispersed completely after every undertaking would lose much of what it had learned. Tools would become incompatible, measurements would drift, and specialized knowledge would remain confined to particular families. But if people returned periodically to a common site, the work itself could preserve and renew the network. The gathering place would become more than a location where something was built. It would become a mechanism for maintaining society across distance and time. Each new project could be larger, because the previous one had produced the organization required to attempt it. Larger projects would then create further demands. More workers required more reliable provisioning. Longer schedules required storage and seasonal planning. Greater precision required common reference lines and standard units. Dangerous operations required recognized supervisors and clearer chains of command. Work extending beyond one generation required methods for teaching people who had not witnessed the beginning. The progression would be cumulative. Small projects would teach cooperation. Repeated projects would stabilize roles. Stable roles would make specialization possible. Specialization would improve technique. Improved technique would permit larger projects. Larger projects would require broader networks, more precise language, stronger logistics, and more durable institutions. At some point, a society could recognize that monumental construction was not merely something its organization made possible. Monumental construction was one of the principal means by which that organization was produced. A mammoth, multi-generational undertaking would then begin to make sense. Its scale would not be chosen only because the builders desired an enormous final object. The scale would ensure that the project could not be completed by one village, one lineage, or one generation. It would compel participation across regions and across time. It would create a continuing reason for people to gather, exchange knowledge, compare methods, train novices, renew alliances, and submit local practices to common standards. People from different communities might arrive with different names for tools, different customary measures, and different ways of organizing work. To contribute to the same undertaking, they would need to make those systems mutually intelligible. A local unit of length would have to be translated into a common measure. A quarrying term understood by one group would need an agreed meaning across the work site. Procedures would have to remain consistent when crews changed, seasons passed, and supervisors died. The project would create shared objects of reference around which language could become more precise. The Yangshan Capstone Hypothesis proposes that the site was ultimately created as a form of external technical memory. It was not primarily intended to communicate a ruler's name, commemorate a victory, or house a deity. Its subject was the process of construction itself. Its forms preserved relationships among cutting, supporting, measuring, handling, moving, and assembling stone. Under this interpretation, Yangshan was a permanent lithotechnical teaching complex, an inhabitable model through which megalithic knowledge could be demonstrated, standardized, practiced, and transmitted. The word model ordinarily suggests a miniature. We make models small because modern models are portable, replaceable, easily reproduced, and accompanied by drawings, labels, and written explanations. But a pre-literate civilization facing a different problem might reverse the logic. What if the model were made larger rather than smaller? A miniature can show what a completed object should look like. It cannot easily communicate what it feels like to stand beneath a partially isolated mass, where workers should position themselves, how temporary supports relate to the weight above them, how ropes approach a handling point, or how access must be preserved during sequential excavation. An enlarged procedural model allows learners to enter the operation. A person can walk through a cutting trench rather than imagine it. A group can stand beneath an overhanging mass and observe how its remaining supports distribute weight. An instructor can point from a projection to an edge, from an edge to a bedding surface, and from that surface to a lever position. Workers can study relationships that would be hidden inside a completed building. In this sense, Yangshan would not be a scale model of one intended monument. It would be a model of megalithic operations. Its scale would serve several purposes at once. The features would be large enough for groups to inspect collectively. Their proportions would remain legible despite erosion. The structure would resist dismantling and collapse. Most importantly, students would be able to place their own bodies inside the geometry. The model would teach not only through sight, but through position, movement, reach, balance, sound, and physical effort. The site would be a textbook that people entered. The most conspicuous objection to the conventional interpretation is the apparent impossibility of moving the largest masses. Under the capstone hypothesis, though, that impossibility actually becomes a design feature. The giant forms were not prepared for transport and then, for some reason, inexplicably abandoned. They were made to demonstrate transport-related principles while remaining permanently anchored to the landscape. A stationary training apparatus can contain handles, joints, controls, and lifting points without itself being a vehicle. Its purpose is to reveal how a comparable system operates elsewhere. The knobs at Yangshan may therefore have represented canonical handling projections. On smaller stones, analogous bosses could have provided points for ropes, wooden frames, levers, protective padding, or controlled maneuvering. On the giant teaching masses, the projections would preserve information about where such features belonged. How far should a projection stand from an edge? How should multiple projections be spaced around a block? Should they align with the estimated center of mass? Should they be located where ropes can apply force without slipping across finished surfaces? Should they remain until the final stage of placement and then be removed? A permanent demonstration could embody these rules without actually requiring that its own bosses ever bear the full force implied by their form. This interpretation immediately produces questions that the unfinished Staley narrative does not encourage anyone to ask. Are the knobs positioned symmetrically? Do their distances from edges form repeated ratios? Are they placed where modelled rope angles would perhaps reduce stress or improve control? Do projections on different masses correspond to different mechanical operations? Are some designed to demonstrate horizontal traction, while others show rotation, stabilization, or lifting? If the bosses are just random residues, such measurements should reveal little. But if they encode a technical system, their placement should prove intelligible. The same inversion applies to the undercuts and chambers. Under a conventional quarrying explanation, every cavity should exist because material had to be removed. But under an instructional explanation, some cavities may have been enlarged or retained to expose otherwise hidden stages of the process. A finished megalith conceals how it was made. Yangshan may have been designed to keep the making permanently visible. But what if the three masses were never intended to form one object? They may instead preserve separate lessons. One could demonstrate the establishment of major reference planes. Another could demonstrate the excavation of deep vertical trenches. Another could preserve advanced undercutting, temporary supports, handling projections, bedding surfaces, or the transition between rough quarrying and precision dressing. Their apparent differences in completion would then be deliberate. An instructional system benefits from preserving multiple stages at once. If every demonstration were completed, the earlier stages would disappear. Consider an anatomical teaching model. It may expose muscles, organs, or bones that would never be visible simultaneously in a living body. Its apparent incompleteness is what makes it informative. Yangshan may operate according to the same logic. A mass left partly attached to bedrock demonstrates attachment and separation. A mass supported on piers demonstrates controlled undercutting. A face that remains rough beside a face that is smooth demonstrates the progression of dressing. A retained projection demonstrates the location of temporary handling stock. A channel that appears unnecessarily large may permit inspection, movement, or the positioning of a full-scale rigging example. What appears to be a quarry frozen by failure might instead be a curriculum frozen by design. This would also explain why no final monument exists elsewhere. Yangshan itself was the completed work, not because every surface was polished or every mass detached, but because the intended subject was the sequence of operations. The lack of inscription then acquires a different meaning. The site would not be mute. It would communicate through geometry. Its vocabulary would consist of planes, intervals, projections, supports, cavities, alignments, and sequences. Its grammar would lie in the relationships among them. This projection belongs at this distance from the edge. This support remains while that trench is opened. This surface must be made level before the adjoining face is established. This access space must remain clear until the load has been transferred. This operation precedes the next one. Such information may be difficult to convey through speech alone because it depends on stable common reference. At Yangshan, an instructor could point directly to the relevant form. The object would constrain the possible meanings of the words used to describe it. The site could thereby stabilize technical vocabulary. A term for a particular type of support would remain anchored to an enduring example. A word distinguishing a rough face from a reference face would have a permanent visible referent. Concepts of alignment, proportion, center, sequence, and conditional dependence would be repeatedly taught through the same spatial relationships. The project could have created conditions that enabled written language to evolve. It could provide concrete reference points in the abstract language domains of causation, planning, geometry, and procedure. To maintain a complex undertaking, people must discuss things that do not yet exist. They must explain why a feature is being preserved for an operation years in the future. They must describe what will happen if a particular support is removed prematurely. They must translate the relationship demonstrated by a giant form into a smaller practical application. That requires counterfactual and conditional thought. If this support is removed, that section will fail. When this face reaches the reference plane, the next trench may begin. The smaller stone must preserve the same relation shown by the larger one. The crew arriving in the next season must continue from this state. The monument would therefore create a recursive process. Construction would demand new distinctions in language. Those distinctions would improve coordination. Improved coordination would permit more complicated construction, which would create a need for still more precise concepts. In that important sense, Yangshan could have functioned as an intellectual catalyst, analogous to the monolith in the classic movie 2001, not as a mysterious object that biologically awakened human intelligence, but as a structure that repeatedly forced people to think beyond immediate perception and survival. Where might such a structure belong in time? The Capstone Hypothesis does not require antediluvian machinery, metal tools, powered drills, or a technologically omnipotent lost civilization. Limestone can be worked with stone hammers, abrasives, fire, water, wedges, and enormous investments of human time. The theory requires duration, continuity, and organization more than exotic technology. A provisional date between approximately 8000 and 6000 BCE would place Yangshan within a long transitional period between the first known monumental communal structures and the emergence of mature writing. Göbekli Tepe demonstrates that monumental construction was already occurring between approximately 9600 and 8200 BCE. Its builders quarried and erected large T-shaped limestone pillars, created repeated architectural plans, and produced extensive relief carving, though notably without evidence of written language. It required maintenance of social networks with contemporary communities across Upper Mesopotamia. The site is now understood not simply as an isolated shrine, but as a settlement with a pronounced ritual component. Göbekli Tepe matters because it establishes that substantial monumentality, specialized craftsmanship, complex symbolism, and communal organization existed before mature writing. Rock art offers another form of durable symbolic communication. At Jubba and Shuwaimis in Saudi Arabia, petroglyphs and later inscriptions accumulated across almost 10,000 years of changing human occupation and environmental conditions. The earliest images are not a script recording spoken language, but they show the persistent human impulse to externalize information, identity, animals, events, and relationships upon enduring surfaces. The proposed Yangshan period would also overlap the long transition toward intensified plant use and rice cultivation in the Yangtze Basin. Archaeobotanical research indicates that rice domestication was not a single invention, but a protracted early Holocene process, with changing harvesting practices and increasing management developing over millennia. This context provides an important explanation for the missing evidence of a nearby population center. A large technical institution need not have been built by either permanently nomadic foragers or a mature agricultural state. It could have emerged among populations combining seasonal mobility, fishing, gathering, hunting, plant management, storage, and increasingly durable settlements. Such communities could concentrate periodically without maintaining a permanent city beside the monument. The necessity of supplying these periods may have been an important motivating factor driving agricultural experimentation and development. The proposed date is therefore not based on the simplistic idea that uninscribed stone must be extremely ancient. It is based on a developmental position. The builders would have lived after monumental construction was already known to be possible, but before writing had become an efficient means of storing and transmitting complex institutional information. They would have possessed sophisticated spoken language and inherited engineering traditions, but still faced severe problems preserving those traditions across disruptions and generations. The 8000 to 6000 BCE window would place Yangshan in the middle of that problem. This fits with our placement of Yangshan as the culmination of a megalithic tradition. Its architects would already have needed experience with stone fracture, quarrying, surveying, ropes, timber, levers, temporary supports, load distribution, and coordinated labor. They would have needed to understand the danger of losing that knowledge before they could conceive of preserving it. The site would therefore imply a precursor tradition. Earlier techniques had been practiced on smaller stones and transmitted through specialist families. Climatic disruption, migration, or demographic decline had likely caused the loss of important skills. Perhaps different communities possessed separate portions of the technical system and needed a place where those portions could be integrated. Yangshan would then represent an effort to consolidate inherited knowledge before it disappeared. This does not require a single earlier global civilization, but it does help explain why megalithic traditions existed worldwide without requiring them to have developed independently. Prehistoric people traveled through structured networks following rivers, coastlines, seasonal resources, kinship relations, and exchange routes. Long-distance obsidian movement demonstrates that materials and information crossed hundreds of kilometers in Northeast Asia long before states and written records. Ideas could move through such networks without retaining the names of their inventors. A handling method might pass from one group to another, be modified, ritualized, combined with local techniques, and eventually appear thousands of kilometers from its point of origin. The most reasonable model is therefore neither complete isolation nor a single uniform worldwide culture. It's really a network of communities in which local invention, convergence, borrowing, migration, and partial preservation continually interacted. Yangshan, under this hypothesis, could have been one unusually ambitious node in that network. Now, why would people travel to such a place? A technical school alone may sound a bit too modern, especially for the early Holocene. But instruction need not have been separated from ceremony, identity, exchange, or pilgrimage. The site could have drawn groups together precisely because its construction and maintenance were treated as sacred obligations. The knowledge embodied in the stone may have been transmitted through ritualized work, initiation, seasonal gatherings, or stories about ancestral builders. People arriving at Yangshan might have exchanged more than just engineering techniques. They might have traded tools and raw materials, arranged marriages, resolved disputes, shared ecological information, coordinated seasonal movements, standardized measurements, and renewed social alliances. The technical and ritual purposes would reinforce one another. Ritual would motivate people to travel and contribute labor. Travel would circulate knowledge. Shared work would create common terminology and standards. The monument would preserve those standards between gatherings. Each new gathering would renew the oral explanations needed to interpret the monument. The site could therefore function without a permanent city. A small resident group might maintain it, while a larger population assembled seasonally. Temporary shelters, kitchens, work areas, and teaching spaces would appear and disappear around a permanent stone core. Its visibility to the entire world would be irrelevant. Its audience would be the network that knew to come. The project would not be a political advertisement to passive spectators. It would be an active institution reproduced by participation. At this point, our framing of Yangshan as a capstone monument begins to take on its full meaning. While earlier projects might have unified communities or regions, an effort of this scale could have done the same for an entire civilization. Its importance would not lie only in the stone forms eventually produced, but in the network of people, skills, obligations, and institutions required to sustain their construction across generations. Yangshan would have provided a common center without requiring the permanent concentration of the population in a single city. Dispersed communities could return seasonally or at appointed intervals, contribute labor and resources, exchange knowledge, and renew their connection to a shared undertaking. The monument would bind distant groups together through participation in the same inherited project. The scale of the work would also bring previously separate forms of expertise into direct dependence upon one another. Surveyors, quarry workers, tool makers, rope and timber specialists, provisioners, healers, planners, teachers, and ritual authorities could not operate as isolated crafts. Each would need to understand how its work affected the larger sequence, creating a more integrated body of technical knowledge. That integration would place pressure on language and measurement. Different communities might arrive with different terms, units, and customary methods, but the stone would demand consistency. Shared surfaces, alignments, projections, and reference points could anchor common terminology, while rods, chords, repeated intervals, and canonical proportions could transform local measures into a standardized system. The project would exert the same pressure on logistics. Sustaining large gatherings over repeated seasons would require reliable systems of storage, distribution, water management, sanitation, shelter, scheduling, and contingency planning. The worksite would become a place where administrative knowledge was practiced, tested, and improved long before it could be preserved in formal records. Authority would likewise emerge from the material demands of the undertaking. A support could not be removed, simply because one crew had completed its immediate task, and a surface could not be altered according to local preference if later work depended upon it. People capable of understanding the full sequence would need the recognized power to coordinate labor, reject defective work, delay dangerous operations, and preserve continuity. Over time, those responsibilities could become offices rather than merely personal roles. The surveyor, master stoneworker, provisioner, teacher, or ritual coordinator would remain necessary even after the individual occupying the position died or departed. The project would therefore encourage the transformation of personal expertise into institutional authority and inherited procedure. Education would become equally systematic. No participant in a multi-generational undertaking could witness every stage from beginning to end, so direct imitation alone would no longer be sufficient. New workers would need structured instruction, permanent demonstrations, supervised practice, and recognized stages of competence before they could contribute to dangerous or irreversible operations. The gatherings surrounding Yangshan could consequently serve many functions at once. A work season might also be a pilgrimage, marketplace, initiation, diplomatic meeting, and period of technical training. Ritual obligation would motivate participation. Participation would circulate knowledge, and shared accomplishment would increase the prestige of the site, attracting still more communities into its network. Technical capability, social organization, and collective identity would form a reinforcing system. Construction would generate specialists. Specialists would improve construction. Improved construction would increase the prestige and attractiveness of the institution, drawing more people into its network. This is why Yangshan would qualify as a civilizational capstone. The monument would be produced by a civilization, but the civilization would also be produced through the monument. Its construction would standardize knowledge, integrate labor, strengthen logistics, formalize authority, train specialists, and create a collective identity extending across regions and generations. The giant forms would be the most durable result of the undertaking, but its deepest product would be the organized society capable of continuing it. The monument would build its builders. This is the deeper meaning of the capstone theory. Yangshan would not merely preserve knowledge already possessed. It would operate as a mechanism for producing new knowledge, new roles, and new forms of cooperation. We can now consider, if Yangshan was an instructional model, how were its lessons applied elsewhere? The giant masses would not be literal templates copied at one fixed scale. They could instead preserve proportional and procedural rules. A boss might be placed at a particular fraction of a stone's length from its edge. Supports might be spaced according to thickness or estimated load. The width of an undercut might correspond to the working radius of levers, or the clearance required for a timber frame. A bedding surface might demonstrate a standard relationship between depth, width, and expected weight. The learners would extract the rule and translate it to smaller stones. That is why enlargement could be useful. It makes relationships visible that might be difficult to perceive on ordinary blocks. It allows an entire group to stand around a feature while it is explained. It allows procedures to be performed symbolically or at partial force without risking a valuable working stone. Yangshan may therefore encode algorithms in geometry. Not numerical algorithms written as equations, but repeatable relations embodied in space. To discover them, researchers would need to stop asking only, how could this stone have been moved? And begin asking, What useful rule would this arrangement teach someone moving a smaller stone? The difference between those questions is the difference between interpreting the site as a failed product and interpreting it as a successful lesson. A technical canon does not necessarily benefit from narrative carving. Decoration could obscure working surfaces. An inscription could tie the site to one ruler or generation when its purpose was to transcend both. A pictorial explanation might become ambiguous as artistic conventions changed. Geometry has a different durability. Gravity does not change. The mechanical relationship between an edge, a support, and a load remains physically meaningful, even after the names of the builders are forgotten. The absence of inscription could therefore be intentional. The site's meaning would have depended upon teachers and traditions, but the stone would constrain those traditions. An instructor could reinterpret a myth, but could not easily relocate a boss or alter the relation between a peer and the mass it supported. The architecture would serve as a stabilizing skeleton for oral knowledge. Over centuries, the curriculum might change, new techniques could be added, surfaces could be recut, demonstrations could be repaired or superseded, yet the great masses would preserve the deepest structural principles. This relationship between durable form and living interpretation may explain why the site could remain useful for a long time and then become suddenly incomprehensible. Once the teaching community disappeared, the physical forms survived without their vocabulary. Later observers would see objects but not operations. Why would such an institution cease to function? One possibility is social disruption. The communities maintaining it may have dispersed, declined, migrated, or reorganized around different economic systems. Another is technological succession. Portable systems of measurement, marked tools, tokens, diagrams, and eventually writing could preserve information more efficiently than a fixed monumental landscape. Writing is mobile. It can be copied, revised, hidden, transmitted, and applied at distant sites. A giant stone curriculum requires people to travel to it and depends on living specialists to explain what its forms mean. Once better information technologies emerged, Yangshan's original function may have become obsolete. The site could then pass through a long period of neglect. Soil would develop in trenches. Water would carry sediment into cavities. Rockfall and vegetation would obscure surfaces. Timber installations would rot. Smaller practice stones would be removed, reused or buried. The durable teaching masses would remain because they were inseparable from the mountain. What would a later civilization make of them? Without the oral curriculum, the forms would invite analogy. An elongated mass might resemble a steely body. A broad mass might resemble a pedestal. A third might be interpreted as a crown. The instructional stages would be reconstructed as components of a single unfinished object. The 1405 Ming record fits naturally into this later phase. Hu Guang did not write a history of Yangshan's construction. He described a court visit to an active stoneworking site. He reported that an enormous piece of good material had been obtained for the Shaoling monument, and his language suggests wonder at a colossal stone encountered in the landscape. He recorded several hundred temporary shelters and material being moved into a deep pit, but he did not describe the creation of the entire visible complex. Under the Capstone Hypothesis, Ming workers encountered a partially buried or overgrown ancient site. They cleared sediment, removed rockfall, and reopened access routes. They worked to quarry at least one major mass, possibly separate from the earlier work. The temporary settlement supported that campaign. With a textual record, later scholars interpreted the giant elongated stone through a familiar category: material for an imperial stele. That interpretation need not have been fraudulent. People understand unfamiliar objects by comparing them with familiar ones. A huge rectangular mass at a quarry near an imperial tomb project could readily become stele stone. This could even have been a misunderstanding contemporaneous with the account, particularly if workers were actively cutting or dressing it. It is also possible that the Ming administration may have explored whether part of the older complex could be appropriated for a new monument. It may have squared surfaces, deepened trenches, removed accumulated material, or attempted to separate a pre-existing mass further. In any case, the surviving historical association eventually grew beyond both what was claimed or what can be substantiated. The surviving historical association was genuine but incomplete. Ming work had taken place at Yangshan, and some mass had been designated for a stele. Over time, that limited episode expanded into a total explanation of the site. 3 nearby forms became 3 components. Their weights were added. The resulting impossibility was explained as imperial overambition. The lack of transport evidence was explained by abandonment. The incompleteness was treated as proof of interruption. A circular narrative emerged in which every contradiction protected the original assumption. The Capstone Hypothesis breaks that circle by separating the Ming episode from the primary creation of the megalithic complex. The proposed reconstruction can now be stated in full. During the early Holocene, provisionally between approximately 8,000 and 6,000 BCE, a society in the lower Yangtze region inherited a substantial tradition of stoneworking and megalithic engineering. Its members possessed spoken language, regional exchange networks, and practical knowledge accumulated through generations, but lacked mature writing as a durable, high-capacity system for preserving technical information. Recognizing the fragility of oral and specialist transmission, they transformed an existing limestone quarry into a permanent educational institution. Its great masses were deliberately oversized and stationary. They were not intended to be transported as complete objects. Instead, they preserved and displayed successive operations involved in quarrying, measuring, supporting, dressing, rigging, maneuvering, and assembling smaller megaliths. The projections demonstrated handling features. The undercuts revealed the relationship between stone and support. The chambers permitted people to enter and inspect hidden operations. Platforms and ledges provided access, working positions, measurement references, or examples of bedding and support arrangements. Different masses preserved different stages of a technical sequence. The site functioned as a civilizational capstone. Its construction and continued use trained specialists, standardized measurements, organized provisioning, integrated regional labor, expanded technical vocabulary, and created long-term institutional roles. It also served as an aggregation or pilgrimage center, where dispersed communities exchanged knowledge, materials, people, and traditions. The monument was simultaneously an archive and a school. Its physical forms preserved inherited knowledge. Its continuing construction developed and enhanced that knowledge. Its scale made the lessons visible, inhabitable, and durable. After the institution dissolved, its oral curriculum disappeared. Sediment, vegetation, collapse, and later quarrying obscured the complex. Ming workers encountered and partially cleared or modified it in 1405, interpreting one or more masses as material for an imperial stele. That episode supplied the historical seed from which the modern 3-component stele explanation eventually developed. For centuries, the Yangshan Quarry has been treated as a mystery, but that mystery has been constrained by assumptions that a few vague claims from a dynasty 6 centuries ago should be accepted as definitive proof of authorship. Archaeologists and historians have whittled away their time asking how and why they would have spent immense resources on a project that could never succeed. The value of the Capstone Hypothesis is that it changes the questions. The theory is speculative, but that may only be because the questions have never been asked in the right way. It opens a new path of meaningful inquiry for research and analysis. Instead of asking only why the Ming failed to move the stones, it asks whether movement was ever their purpose. Instead of asking why projections and surfaces were not finished as decoration, it asks whether they encode mechanical principles and processes. Instead of asking why the separation would have been begun if it could not be completed, it asks whether cavities and cut-throughs were designed as example demonstrations for access, inspection, and teaching. Instead of asking what prevented inscriptions from being left to explain the site, it asks whether geometry itself was being used as durable information. Instead of summing three masses into one imaginary monument, it asks whether they preserve separate stages of a curriculum. And instead of assuming that a temporary Ming settlement created the entire site, it asks whether the Ming were clearing and adapting something already old. Most archaeological discoveries begin with a new answer to an old question. Occasionally, however, progress begins with recognizing that the old question was built upon an untested assumption. Yangshan may not be asking, how were these stones supposed to be moved? It may be asking, how was the knowledge of moving stones supposed to survive? If that is the correct question, then the apparent absurdities of the site begin to align. Its scale made the lessons inhabitable. Its immovability made the archive permanent. Its incompleteness preserved the stages of work. Its knobs demonstrated handling principles. Its cavities exposed hidden operations. Its lack of inscription reflects a world in which technical knowledge had not yet been detached from objects, bodies, places, and teachers. The construction effort itself produced the specialists, measurements, vocabulary, logistics, and institutions needed to continue construction. And its later misidentification arose because the civilization that understood its geometry had disappeared, leaving subsequent observers to come up with an alternative purpose for a monument that embodied technical language they could no longer read. The Yangshan Capstone Hypothesis is therefore not simply a claim that the site is older than the Ming dynasty. It is an alternative explanation for the ancient purposes of monumental construction itself. Before books, a civilization may have built its knowledge into the landscape. Before engineering manuals, it may have created places where people could enter the process itself. Before measurements were written, they may have been preserved as relationships among permanent forms. Yangshan, in this interpretation, was neither an abandoned stele nor an inexplicable display of excess. It was a machine to enable civilization and make it remember its purpose.